Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Half Circles by Dorlier. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case is a box. We have a digit n placed inside a circle or semicircle indicates that exactly n full circles in the grid contain the digit n. Two semicircles together count as one full circle. For example, if there are, say we had 4 semicircles containing the digit 5. So say we had 5, 5, 5 here, and 5 here. And three full circles containing the digit 5. Say we had 5, 5, 5 here. Then the total count is 2, which is the semicircles, plus 3, which are the full circles, equals 5 circles with the digit 5. So this is, if you've played this before, it's similar to, if you've done other puzzles, there are circle puzzles where you basically count the number of digits in circles. But here, a semicircle counts as half a digit, essentially. So this is half a digit containing 5, or half a circle containing 5, 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 all adding up to 2 circles containing 5 for these 4 cells. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. There's a lot of circles here. Let's count how many total circles there are, which means counting how many half circles and counting how many full circles there are. And that will tell us how many total digits we need in the circles. So 5 half circles, another 5, so that's 5 circles in total. 6, 7.5. Now let's count full circles right now. Oh, it's hard to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 full circles. How many half circles? 5, 10, 13, 17, 21, or 5, 24, 27, 5, 32, 37, and then 40. So there are 20 full 20 half semicircles. Sorry, no, 20 full circles from the 40 semicircles. There are 16 full circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 36 total digits. That means we're missing 9 digits worth from 1 through 9. So it could be the 9 by itself. It could be 1, 8, 1, 2, 7, 3, 6, 4, 5, or missing like 1, 2, 6, 1, 3, 5, or 2, 3, 4. Do we ever have, oh, we have to be missing a complete digit. I think we cannot be missing 2 digits. And the reason why we know that is because if we were missing 2 digits, this would not be possible, right? So every digit but 1 digit must be in a half circle, in a semicircle or full circle. So that means that many digits have to be in it. Well, that means the digits 1 through 8 have to be in the semicircles or the circles because they are in part of 1. Therefore, all the empty spaces must be 9. Where we have where we have single empty spaces. And this is 9. That's the only digit in that box which doesn't have a circle or semicircle. So this must be 9. And then that must be 9, because that's the only space which doesn't have that semicircle. And this is not 9. This 9 eliminates 9 here, so this must be 9 there. So all the 9s avoid all the circles. So this can't be 9 then. This can't be 9, so that makes this is 9. Well, 9 can't be here, so 9 can't be in the semicircle, so 9 has to be here. In this upper central box, or actually rather row 4, we have a guaranteed 9 here. Nine cannot be here or here, so 9 has to be here. 9, we have 8 9s now, which means that has to be 9. So 1 is interesting in that 1 can only be in one's full circle or 2 semicircles. Well, it has to be in 2 semicircles then in this lower right-hand box and this lower central box, which means 1 cannot appear in another semicircle or another full circle in any of the other boxes. So that means this must be 1. So 1 can't be here. 1 has to be here. 1 can't be here, so 1 must be there. 1 has to be one of these 2, but in this right central box, 1 has to be here, which eliminates 1 from the rest of the row, so this can't be 1, which makes that 1. Where's 1 in this upper right-hand box? Cannot be here, so it must be here. And we have, in this upper central box, 1 has to be there. Because, again, in this lower central box and the lower right-hand box, we are guaranteed a 1 in one of the semicircles. So where's the 1 in column 7? Can't be here because 1 in the box, can't be here because 1 in the box, can't be here because 1 in the row, so it must be here. And then in column 4, where's the 1? Cannot be either of these because of the ones in the rows, can't be here because of the ones in the boxes, so it must be there. Okay, so we have 9 and 1 accounted for. 2 might be similar. So, how many boxes now have to be 2 on a semicircle or circle? And we have 1, 2, 3, 4 boxes which have 2. So they must be in the semicircles in those boxes, which means it cannot be 2 in all the other boxes. So this has to be 2. This must be 2. 2 could be either of these. 2 could be either of these. So since 2 has to be guaranteed to be one of those 2, and 2 has to be guaranteed to be one of those 3, 2 must be one of those 3 there. 2 has to be one of those 2 there. 2 is always a half circle. So in this right central box, 2 has to be one of those 2. And in this lower right-hand box, 2 must be one of those 3. 2 has to be one of these 2 to be empty because we have half circles already in all the other places. Okay, let's look at 8. what can 8 be in this upper left hand and this upper central box? It has to be part of a semicircle, which means in the rest of the boxes, it has to be full circles, because this semicircle means we have accounted for 2 8s in the puzzle, which fill only one circle. So the rest of to be able to fill 8 circles, the rest must be full. That means this must be an 8 here. In this left central box, this must be an 8, which eliminates 8 here, so this must be an 8 here, which eliminates 8 here, so this must be an 8 there. This 8 eliminates 8 possibly here, so this is 8. This can't be 8, and this can't be 8, so the full 8 must be there. And this 8 and this 8 eliminate these 8s as possibilities, and the 8 here and the 8 here eliminates these as possibilities, so this must be 8 there. So we're looking for an 8 in column 1, cannot be here because of the 8s in the boxes, so this must be 8 here. In column 4, we're looking for an 8, cannot be 8 here because of 8 in the boxes, can't be here because of 8 in the row, so this must be an 8 there. Okay, so similarly, what about 7? 7 has to appear in a semicircle here, a semicircle here, a semicircle here, and a semicircle here. That means for 4 7s, that only fills 2 circles. That means the remaining 5 7s must fulfill all the remaining full circles. So this must be 7 here. This must be 7 here. Those are the only remaining big full circles we have. One of these is 7. This 7 eliminates 7 here, so this must be 7. This 7 eliminates 7 here or 7 here, so this must be 7 because that must fulfill a full. That leaves that as a 7 there. So, where is the half circle in upper left-hand box? It must be one of these cells for 7, which means 7 cannot be here because of 7 in the row, neither here, and cannot be here. So this must be a 7 here. Where is a 7 in column 4? Cannot be here because of the 7s in the boxes, and these are filled out, so that makes this a 7, which means this can't be 7. Where is a 7 in column 7? Cannot be here because of 7s in the boxes, can't be here because 7 in the row, so it must be here, which eliminates 7 here, so this is 7. So now we've accounted for 9s, 8s, and 7s. 6s... We have only 3... Okay. We have 1, 2, 3 full circles possible for a single digit. If we don't have any fulls available in the rest of the boxes, that means they can only be half at most. So 6 would be half at most for 6 boxes, which means it counts for 6 boxes, which means that counts for 3 circles at most in the rest of these boxes. Since that accounts for 3 at most in the rest of the boxes, and we can only have 3 fulls in the other remaining boxes, that means the 6s must be in those 3 full cells. So this is 6, this is 6, that's 6, because then it adds up to 6 as a total. 6 has to be then in the half circles, cannot be here in this upper right-hand box, so it must be here. It must be one of the half circles here, so it can't be here, so it must be here. And then it must be one of the half circles here, so it must be here. That means we still have 3 more half circles it has to be part of. 6 can't be here, 6 can't be here in this right central box, so 6 must be there. 6 cannot be here, so it has to be one of these 2. So 6 eliminates, so in column 1, 6 can't be here because of 6 in the box. 6 can't be here because 6 in the row, so this must be a 6. In column 4, neither of these two can... This can't be 6 because of 6 in the box. These can't be 6 because 6 in the row, so that leaves that as a 6. Okay. So, for 5, we only have one full cell circle left. If it's a half circle in all the remaining boxes, that's 8 times half, which is 4. So that accounts for 4 5s, which the one full 5 would make full circle and make it a 5. So that means this is 5. 5 has to be in all the remaining half circles in each box, because then that adds up to 5. 4 full circles, 4 full circles from the 8 half circles, and 1 full circle here. So that means this is a 5. This can't be 5 because of 5 in the row, so this is a 5. This can't be 5 because of 5 in the row, so this is a 5. 5 cannot be here, so in this central box, 5 has to be one of those two, which eliminates 5 here, so that means 5 has to be one of those two in this lower central box. 5 cannot be here. In this left central box, 5 has to be here, which eliminates 5 here, so this must be 5 there. Where is the 5 in column 7? Can't be here because of 5 in the box. Can't be here because 5's in the row. So this must be 5, which means this can't be 2. So therefore this is a 2. That eliminates 2 here, so this must be 2, which eliminates 2 here, so that must be 2. These 2's are eliminated, so that must make that a 2. Neither of these can be 2 anymore because of the 2 in the column. Where is the 2 in this box here then? It has to be here. This 2 eliminates 2 here, so where's the 2 in this box? It has to be here. These two 2's are eliminated. That forces this to be a 2 there. Where's the 5 in column 2? Cannot be here because, or here because the 5's in the boxes, and these are filled out, so this must be 5 here, which eliminates 5 here. That makes this a 5 only in this lower central box. So we should have all the 2's and 5's now, and now we just have 3's and 4's we need to fill out. 4 has to be, since there are only semicircles left, 4 has to be in 8 semicircles. Well, 4 cannot be in a semicircle here, so that means the remaining 8 boxes must contain 4 in a semicircle. So this is 4, this is 4. That leaves 4 in row 3 being here. And that leaves these as 3, because that's 3 in the corner. Now we have 3 and 4's being in semicircles in the remaining boxes. So we just have to do normal Sudoku now. Right. This becomes a 3-4 pair. Everything's a 3-4 pair. We're going to mark this as red and this as green. That forces this to be green, which forces this to be red, which forces this to be green, this to be red. This red means this has to be green, which means this has to be green. This is red. This 3 means this can't be 3. So this must be 4. Therefore, the greens are 3 and the reds are 4. This 4 eliminates 4 here, so that's 3 and 4. And that's a solution. Yeah, the logic behind this was pretty solid. You'll often run into these circle puzzles, but this is the first time I've ever run into these half circles puzzles, which is actually makes it very interesting, right? There are certain restrictions you have in full circle counts that you don't have in half circles as much. But there are other restrictions that are more restrictive in these half circle puzzles, so that's interesting in itself. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.